Right. So how do you want to do this? Do you want me to just talk you through concept, or do you want to ask questions and I will try and answer them?
Oh, let's start from your, like, I don't know, quick review of this memory structure. And then I will ask questions if I will have.
Okay. Well, we've got a detailed video of the link breakdown. I wasn't going to review all of that in detail unless there's a specific aspect of it that we need to go over.
I saw this video actually.
Okay.
I saw it. But I saw. Okay, I can start with my questions. No problem. So I heard there that you asked Patrick about the problem with distribution of the concepts if we will use these term links and task links. Yes.
Yes.
Because it might be a problem. And you said today in a channel that you can group concepts with overlapping terms in one place or something like this. Do you understand me? I hope, because my English is terrible.
No, it's fine. That's perfectly understandable. Yeah, so,
I'm happy.
So the key thing there is one of the features of Galaxy is that it automatically clusters data into usage groupings. So if a concept calls another concept which happens to be on another distributed node, it will move them around so that they end up in the most efficient allocation of distribution.
I'm afraid that as we will have a lot of a relation there, that we'll have a problem anyway, because even if we have some group of concepts that are connected with that term links, they will be coupled with other group of concepts anyway, and I'm not. It will be a problem.
Absolutely, it's true that there will be. It's not going to remove the problem completely. That's absolutely the case. It will. It will significantly reduce it.
Okay, I see.
There's a degree of assumption in here based on prior work in other systems that concept clusters they're strongly connected to each other within the cluster, and only weakly connected to other clusters. And there's quite a lot of theory that supports that, although we haven't got any practice of that. So the point here is that yes, there will be connections to other clusters that may span nodes within the cluster, within the distributed nodes, but there will be far fewer than exists within a clustered group of concepts. So whilst it doesn't remove the problem, it actually, the fact that they get moved around by Galaxy to places where they're most frequently used will significantly improve the situation.
Okay, I got it.
Yeah. So that does link into the other point. Was could we not include everything inside of a concept so it doesn't have to have external links? And that was the other part of the discussion I was trying to explain today, which is it's fine until you introduce the occurrence time, and then you end up with this combinatorial explosion problem because of the fact that a table now includes different content and different occurrence time. So you end up with this big O n squared problem in terms of search space, as opposed to just big O small n, big O n search space if you're just using occurrence time or content. And because we have to put the occurrence time somewhere, the decision was made, it went into the tables. And I'm happy to explain that in more detail if you need me to. I'm not sure that's entirely clear from my explanation at this point.
So let me ask a question. So as I understand, before we we can have concepts that contains all the related data, but if we will have this occurrence time, it will be a problem for us. You say that we will have the same content in beliefs or goals, but with different occurrence time.
Yeah,
is it correct?
There's two approaches you can take. If you ignore NAL 7 and beyond for now, so up to NAL 6 inclusive, it was quite possible to have all the beliefs related to a term inside of the concept where that semantic relationship was managed, and you didn't need any links, and you could do inference from within the term, from within the concept, because you could grab a task and a belief from within it. But once we introduced the temporal aspect and occurrence time, there was two options. It was either we could add occurrence time into the concept. This is where you got the explosion problem, the combinatorial explosion, because now you've got all these different beliefs, and for each different belief, you've got all these possible different occurrence times as well. So you've got an n squared problem, and that just became unmanageable because that ranking process is done on every single task that goes into it. So every time you execute a task, you have to re-rank the table. And it was just completely impractical to do that.
I actually don't understand why we have to like store both versions of the same belief. If we have two entries with different occurrence time, why we have to store both versions?
Well, that is what we do now, yes. But the other thing is the fact that there is no content that's different within a table. So in fact, all a table has to have is an occurrence time, and you don't even need to store the content because it's the same for every entry in there. So all it really is, it's a list of truth values, budgets, and so basically just metadata. That's all there is in a table, is just metadata. And the table itself represents the content. So it's much more efficient in terms of storage and processing time.
Yeah. Anyway, I don't understand now all these things.
Okay, I can explain each of the points in detail at some point, not a problem.
I'm waiting for my questions. Actually, I'm thinking because I didn't hear. Are you there?
Yeah, I'm here.
Okay, great. I still don't understand what is the difference between this old version where we don't have this occurrence time and this new.
Okay. Let me take it back a step then. So we'll just talk about the old version for a minute. So imagine in the old version, a concept contains two bags, a bag of beliefs and goals and a bag of tasks.
Yes, got it. Okay.
Okay. To carry out an inference on that, all you need to do is take a task out of the task bag and a belief out of the belief bag, and you can do an inference, and it's all local in the sense that you don't need to traverse any links to get any additional data. So that's a single isolated processing unit.
Yes, got it.
Okay. Now imagine we add in the requirement to manage time as well. So every one of those beliefs and tasks now gets an occurrence time.
Okay.
In order to process the time, we have to process things differently now, because you can't just grab a belief and a task. So if you take a task out of the task bag, we now need to pick a belief that's relevant to the occurrence time for that task.
Whoa, okay. What does mean relevant in this case?
Okay, so if you have a task that says this is an event about 10 cycles in the future, you now need to look through the beliefs for any of the beliefs that have a semantic relationship that also relate to 10 seconds in the future, or 10 cycles in the future. But it's worse than that, because the confidence of one that's 10 steps in the future might be lower than one that's 9 steps in the future. So what's better, to pick the one that's got exactly the same time step with a low confidence, or one that's got 9 steps in the future but a high confidence? So what we do is we have this concept of projection, where we take the confidence, the truth value, and we project it based on the time of the task to the same time as the task. So if it's the same, then the confidence doesn't change. If it's 9 cycles versus 10 cycles, then it's a slight adjustment. It basically reduces the confidence by, for example, 1/10.
Okay, but what if we have like 5 cycles difference, 6, 7, 8?
Yeah,
what we will choose?
and it's the same thing. So the difference is proportional to the variance in the time between the task and the belief, and there's a formula that calculates that. So it's quite possible that a very high confidence belief that's actually quite a long way in terms of time
Yes, I
away
got
from
it.
the
I
task
understand.
could be selected. So that's kind of the challenge here, is that once you start adding in different times as well as different contents, every single belief could have 10 temporal variations. And if you've got 200 beliefs in a bag, and then for every one of those 200, you've got 10 temporal variations of each one of those, you could potentially have 2,000 very easily, which is way too many to process in a ranking perspective, as you have to do it every task.
Okay, I have another question. The only difference between that beliefs will be occurrence time, or maybe maybe there will be another difference between these beliefs. I don't know, like I don't remember this term. I have to check it. Okay, this will be the only difference between beliefs. I mean, occurrence time.
Okay. Typically, there'll be a difference in occurrence time and in truth value. Not necessarily, but typically, it could be that the only difference is occurrence time. Yes.
Okay, but evidential base, I remember this. Evidential base, it will be the same, or it can be different.
Oh, actually, no. Sorry, evidential base will be different as well. So the only thing that you can, in fact, let's think about this. The only thing that is guaranteed to be the same is the contents. Everything else could be different. So the occurrence time could be different, the truth value could be different, the budget value could be different, the evidence could be different for every single belief.
So the difference here is that when we have this temporal stuff here, we like have more complex algorithm for selecting of beliefs for inference. And as a result, we have more beliefs in this table or bag.
We would have, yeah, if we kept the same, if we kept all the content that originally would have been in the bag before we changed to the occurrence time management of bags, then there would have been a huge amount of content in there, which is why we introduced the links, the term links, to take out.
Okay, the next question is how these links help us to avoid any problems here.
Okay, so what the links do is they move the non-duplicate content out of the bags. So they basically sort of out of the concepts, and they go into their own concepts. So a concept really it's only about a single term. It's always about just a single term, never more than that. but it can have a lot of information about that term, what that term is linked to, i.e. the term links, and that term can be linked to many different possibilities, depending on how big the term link table is. It can be part of many other concepts, and also it can have many different tasks in a similar way to term links. Task links link it to tasks in the same way, but the actual definition of the concept itself is only about the exact term that it refers to. So there's nothing
No,
in it.
I understand this. I understand this from the session that I saw with you, Patrick and Jared. Okay, I understand this, but I still don't understand how it helps to avoid the problem. I understand how it works, but I don't understand how it helps.
Essentially, what it does, if you imagine all the term links and what they're connected to, if they were moved back into the concept, that's what the concept would look like internally, and that is, in fact, that kind of is the answer of why we took them outside the concept, because it was incredibly difficult to manage with all of it inside the concept. So all those term links and the concepts they were connected to and all the beliefs related to those, for sort of one level out, they used to be inside the concept. But now they've been taken outside the concept. I don't know, does that help visualize the problem or not?
Yes, but my question is still the same. I don't understand how this. I understand that they are moved to other entity and they are now out of the concept, but I don't understand how it helps to avoid any problems.
Okay,
it is about sharing of memory.
Yeah, it depends what the problem is that you maybe you haven't seen the problem yet. Because now the concept only has a single content type, it's easy to reason about. So if, for example, a concept might say cat is an animal. So within the belief table inside of that concept, it will only have cat is an animal in there. Now, historically, before we made this change, for example, that if that concept was called cat, for example, then within that concept, in that belief table, there would be everything related to cats. Cat's an animal.
Yes, I understand this.
Okay, so now, now when we come to do task projection on that table, we now have to do it for a huge number of objects, or limit that number of objects significantly to make the task manageable, because we have to store all the occurrence time variations for each of those statements, whereas now we only have to store the occurrence time for one statement. Right, so there may be 20 occurrence time variations for the statement that represents that particular concept. So cat is an animal, and there could be, let's say there's 20 in the belief table. Now before, there would have been 20 beliefs that would be different to each other, plus each one of those would have had 20 variations from a temporal perspective as well, so 20 different occurrence times. So there would have been 400 beliefs in there to try and get the same level of comparison to just holding 20 beliefs. So that's the squared problem. So this is the problem it solves by putting the links, the term links in place. But now when we project, we only have to project against 20 beliefs instead of 400 beliefs. I know I'm repeating myself, but that is the problem that this solves.
Okay. And
maybe
this.
I'll understand your problem more as we discuss it. Maybe I'll go, oh, that's what you mean, because I'm not. I think I'm missing what it is at the moment.
I don't understand. Sorry.
I'm just wondering whether, as we keep talking, maybe I will understand more about how you're seeing the problem differently to me.
Okay. I don't actually. I just try to understand what the problem here. You said that okay. In new version we have this 20 beliefs within the concept, and in previous version we can have like 400 of beliefs. And so when we just try to find a belief for I don't know, revision choice for inference, I mean general inference, we will have some problems in this case because we have a lot of beliefs there. Is it the case? Not.
Actually, for general inference, no. This is actually only an issue for local inference.
The issue for okay, cool. That's like some kind of things that I wanted to hear. Yes.
Yeah, general inference is just about selecting a term, basically a task and a belief. I mean, that's all it has to do. It doesn't need to do any processing within the concept. It's the local inference that does the processing that requires all of this state management.
Okay, so in case if we have this all these beliefs inside the concept, we have like new task with some judgment, and so we have to don't know, push this task to each concept that can contain this belief, and then try to find this belief and make this revision choice or projection, like you said. And
that's basically it. So when a task is received in the concept, the first thing it tries to do is local inference, and the type of the task will determine what specific operation. So there's really three. There's revision, there's choice, and decision. They're not mutually exclusive because decision can happen as well as one of the others. But that's really the only three things that can happen: a revision, a choice, or a decision. And the way that happens is it uses basically what we were discussing now, the state of the concept. So if it's a belief that comes in, it will check to see if there's a matching belief in the belief table.
Yes.
And it will do a projection first to check it's matching the relevant occurrence times. So for every operation on local inference, it does a projection on the belief or goal table, depending on what the task type is. And then it will select the most, because remember, every belief is exactly the same, so it doesn't have to search for any content type.
Yes, I understand this.
Yeah,
I understand this, but
go on.
But what if we have the map here? I mean the map like where the key will be this statement, or like you called it. I don't remember. Okay, this belief will be like the key. So we will find all these different occurrences of the belief quickly, and we will make all this revision choice and other stuff, and we will be happy with all this data inside the concept. I don't see any problem in this.
Okay.
Is it possible, or?
Yeah, it's straightforward. Local inference is not hard. It's very straightforward. It is simple as doing the ranking function against the table and then picking the best confidence, and that's it. that is all that's involved there. Then you just apply whichever the inference functions is, whether it's choice, revision, or decision. Decision involves a little bit more because it has to actually execute an operation, but that's just a message that gets passed out. So yeah, there's nothing complicated about that at all. It's very straightforward. It is literally task comes in, the table is ranked by the task occurrence time. We pick the highest confidence.
Okay, I mean that I don't see any problem in like the storing all these beliefs in concept. I mean, I don't see any problem in old version because we can have a map of beliefs here. So we don't have we don't need to have a table or back of all these beliefs like plain table. We can have a map before, and the search for belief will be very quick. So
yeah. So there's kind of the two things that the concept processes. Local inference,
yes,
just uses the tables, right? So it doesn't use the term link or task link bags. Doesn't need them.
Yes, I understand. Yes, of course.
And then the other side of it is the general inference just uses the term link task link bags and it doesn't use the tables.
Hello.
Okay. Hello, Patrick.
Hey, Patrick.
Patrick, hey, glad you could join us. Or not.
I can hear you.
Oh, good. Okay, great.
Okay, so now I feel that I got your idea, and actually I understand why you prefer to use these task links and turn links, but I'm not sure that we cannot avoid these term links and task links.
Okay, yeah, I understand. Go on, Patrick. You have a go, Patrick.
They also provide a benefit for the system because the links have a budget themselves, and this makes it possible for the system to learn to associate different concepts with each other. And this is very, very important because the system learns context. By this, for example, concepts which are related and important in similar situations automatically begin to activate each other through this term link system.
What does it mean, activate each other? What actually this means?
When a concept is selected for inference, how should I say? At first, a task link is selected, and then a term link is selected. But the budget of the links determines which links have a good chance to be selected, and this means that specific connections to other concepts, although they are semantically valid and although all the semantic connections are there, it might be that only a small percentage of connections between concepts is strongly used because the budget of the more used links can be significantly higher than the budget of the not used links.
Okay, I see this, but in previous version where all the data were in was in this concept, there was no this links, and there was no like budget and how it worked before.
Yeah, Roman, the way it worked before was that each subterm of a concept had its own concept. So it worked in a similar way but it wasn't as flexible. So imagine that you've got a term cat animal. There would be a concept for cat and animal. Then cat would have a concept and term would have a concept, and they would get updated in a similar way as the way term links work now. You still have to find each of those concepts, send a budget update to them, so that they would recognize the fact that they had been activated. So
and in which case, in what case they will be like updated?
Yeah, it wasn't actually that different a process from managing the links, which is why I think either way, whichever way you go, you end up having to duplicate this link structure, either explicitly like we do here with term links, or implicitly by just updating the budget on sub-term concepts somehow. I ended up having to do that, even though I didn't use the term links directly. I still had to update the concepts that they were associated with, which meant I had to send these update messages to change the budget. So it actually doesn't really simplify anything. You still end up having to talk to all the sub-term concepts because you have to change the budget.
One question here: how do we? What's the reason for this update when we update these budgets?
Oh, okay. But budget updating is the heart of the control system. So it's the attention mechanism basically. So updating budget, it determines what gets selected when, and that is really that's what makes the whole thing work. That's kind of a whole new discussion, really. I don't want to open a can of worms on attention at this stage, because I think if we start that one, we'll end up going down a rabbit hole.
And you think that there is no like a quick explanation of this? I mean,
well,
I don't know.
Yeah, a quick explanation is, think of it as activation spreading in a neural network. What's connected affects things that it's connected to. It's not as simple as a neural network in some ways, but essentially it kind of spreads out. You can imagine that if something fires and whatever it's connected to, they get fired slightly less, and whatever they're connected gets fired slightly less. That's one aspect of it, but there's also another aspect where tasks drive attention as well. So there's kind of a couple of dimensions to this.
Okay, so I just will imagine. Okay, we have like new task, team cat. Yes, this typical task, and then it means that we will update the budget of team cat concept, and the budget of cat concept, and the budget of team concept.
Yep.
Somehow, yes.
Yeah.
Okay.
And actually, Tim is actually a two-level concept because it's an instance. So you'd update the instance Tim, and then that would propagate further to the actual item Tim as well, which would be another level down.
Okay, can you repeat this, because I don't understand this?
Okay, so Tim is an instance of an object, yeah. So it's got the curly braces around it. So curly brace.
Oh,
Tim,
okay.
curly brace.
You mean this braces? Okay.
Yeah.
I got it.
Yeah.
No
So
problem.
then Tim as well is another level down.
I just imagined all this stuff without braces. Okay, but I understand. And I saw in that session that you had with guys that this like parsing of statement goes to 3 levels deeper. Something like this. I hope
that was for concept creation.
But I went through rules, and I found only a few rules with conjunction that have these 3 levels.
This is
inside.
true.
Yeah, that's correct.
So actually, okay.
So
Okay, it's good.
be very, very careful to not create too many sub-term concepts, because it influences the budget system negatively. And so we looked at the inference rules and saw that only those which had the conjunctions in it demanded this additional level. And
Yes,
this is why,
okay.
why
Great.
we didn't allow it for the others.
That was my decision for deriver, because I had the same problem on premises matching. So, okay.
But be careful not to mix up concept creation with budget propagation, though. Concept creation will only create to maximum of 3 levels, but budget propagation can propagate, right throughout the system if necessary. So it isn't just necessarily limited to 3 steps. Although it will only create 3 levels of concepts deep, but if that happens to be on top of an existing hierarchy, budgets can propagate much further through a hierarchy than 3 levels.
Okay, you mean, yeah, but then it will stop actually, because I can imagine the graph of this concept that it will be cycled, and if I understand.
Obviously, at some point it gets to a minimum threshold and you just stop.
So
every time it gets propagated, it gets reduced. So it gets reduced by, for example, the strength of the link. It will get weaker and weaker as it propagates out, and at some point it reaches a threshold where it's below that point, so therefore it doesn't get propagated any further.
I don't understand.
Okay, so imagine you've got a concept in the center of a hierarchy. It propagates out to all of its term links with a certain strength. Each of those term links has a confidence or a budget value of its own. The propagated value is multiplied by a factor within the link, so it's reduced essentially, because everything's below 1, so it gets less and less. So the further it propagates away from the starting point, the less and less it gets. And at some point it reaches a predefined threshold where we say if it's not above this, you don't propagate it any further. So it's possible for it to travel down one branch of the hierarchy that's very high level, high confidence, high strength, and go further than it would do if it went down a different branch where the confidences and budgets are low, because it'll reach the threshold faster.
Another question: this propagation, it can go only one direction, or it can be some cycle there in this propagation?
Oh, I see. That's a good question, actually.
It only goes one way.
Well, it only goes down links in one direction, but if those links happen to come back again, yeah, that's a good point, actually. I mean, it does only go one way, but it just follows links. So if it finds another path, it's actually no. I don't. Well, it's possible. It is possible.
Yes.
Similarity is asynchronous, so it could be cyclic, but it's not a problem because it will always reduce and it will hit a threshold at some point. So in some ways, actually, cyclic propagation is probably a property you want as opposed to a negative.
Okay. Sounds strange actually, but no problem. Because I imagine this propagation goes with a cycle, and at the one moment we will have a reduced budget of all concepts.
It won't reduce a concept. It won't reduce a budget. It will only typically increase them.
Okay.
Yeah. They don't get reduced. They only get in. Sorry, probably my language has been confusing you there. Budget is an incremental process typically. Well, it will typically add to the existing activation level, but the amount it adds will reduce as it propagates through the network.
Okay, I hope I
Yeah.
understand something.
Yeah, sorry. Yeah, good point. Yes, it doesn't reduce the activation within concepts. There is no negative or inhibition within the system. They decay basically, and that is kind of the only way they can actually get less. There isn't any inhibition.
There is no any way for them to get less?
Only decay.
Decay is like, what is this?
It's basically, it's a function of time. So based on number of cycles, there will be a kind of an exponential decay curve of the attention values. So they will reduce over time. We have looked at, and I've done quite a lot of work with inhibition, but it's turned out to actually not be necessary. And Pei is also of the opinion that there's no need for it, and there's no basis to support it. I know neurons use it, but we're not using neurons, and I think I won't go into it now, but I can give you a long-winded explanation of why inhibition really isn't necessary.
No problem. You don't have to do this. I just wondering how. As I understand, there is a process with like forgetting of these concepts.
There's two pieces that reduce it. There's this what we call the forgetting function itself, the decay basically as a function of time. And there's another one which is basically we call cost of inference. So whenever you take a task and a belief, and you apply inference on them, we say there's a reduction in priority because of the cost of doing that inference. Those are kind of the two ways that attention is reduced in the system.
One moment. So if we use some concept in general inference, we reduce its budget.
Yes.
All right, its priority.
Yeah, its priority is reduced by its durability. So you multiply priority by durability, and it gives you a new priority, which will be less.
Okay. Okay.
So if you can imagine the worst case, well, you can never have a priority and a durability of 1, because it basically would mean it would last forever, and we don't allow that in the system. But you can have a priority of 1 and a durability of 0.99. So when you multiply those together, the priority only falls very slowly. But if you've got a durability of 0.1, then obviously priority would fall very rapidly. If you're multiplying 1 by 0.1, it does an inference, and it's 0.1 again. So it only probably gets one shot before it's removed from the system because of low priority. So the durability is really important. Yeah.
Okay. I'm thinking like about other questions. Maybe I have something.
The other thing what I wanted to say, I don't think that it's necessary to create a activation which distributes itself through the network. Everything which was done in the design we had was activating the subterms of the concept in the hope that inference itself will make sure of further activations.
Oh yeah, sorry, I see what you mean. Yeah, you're right, Patrick. That's a better way of explaining it. Yeah.
Right. So most activations are done by inference itself, and not by
propagation.
Propagation, right?
Yeah.
So propagation just affects on priority of these concepts in future.
But the propagation in the design we had only affects the sub-concept. So, for example, if you have a concept which says that cats are animals, and when a statement cats are animals enters the system, then cat and animal gets priority. But if there would be sub-concept of cat, okay, in this case it's not, but if this would itself be a compound concept with sub-concepts, then the activation would not go deeper.
Will not go, yes. It will
Yeah.
stop on this concept.
Right.
Yeah, that's a better way of thinking about it, Roman. I may have confused you when I was talking about propagation through the network.
Okay.
Explicit propagation only goes to subterms. Implicit
Right.
propagation, which can traverse the whole network, happens through inference. So when you select terms, they then go backwards a level or forwards a level, and they can then further propagate. So it's not an explicit activation spreading from every node to every node. It's one level explicitly, and then inference will then do the implicit activation at the next level, and so on.
Okay.
And another relevant part, because you might wonder how the dumplings get strengthened, how they get strengthened, and how they get weakened. And here it's a simple principle. Whenever a dumpling is selected, its priority gets decreased, as Tony already said. And additionally, if two concepts are active at the same time, and let's say we choose both concepts for inference with each other, then the strength of the link between them gets strengthened according to the priorities of both concepts, which means when both concepts are active, the link between them gets stronger. So, which has the effect that when next time just one of the concepts gets activated for some reason, the other concept automatically also gets activated through this link. So has a high chance to interact with the other concept, or to, how should I say, has a high chance of selection because the link between the concepts grows strong.
Yes, I got it.
Yeah, this is Heb rule. If you're
Right.
familiar with that, concepts that fire together wire together.
No, I don't know about this.
Okay, no problem.
Okay, I feel that I don't have any questions more. Maybe someone has. Sorry.
You're probably out of time, aren't you, Roman?
No, I have time.
You have
It's
a
not
few
a
minutes.
problem.
Oh, okay. I didn't want to overshoot if you needed to go. I know you said till 6. Okay, I had a question for Patrick actually, which I didn't get an answer to the other day, which was how did the implementation of the curve bag work?
Oh, sorry, I didn't write the details.
You didn't tell me, no. Just in rough data structure terms is fine.
Let me think. At first, there is a priority curve, and this priority curve gets discretized according to the amount of elements in the bag. For example, if we have a priority curve between 0 and 1, then, and we only have 10 elements in the bag, then the resolution of the curve, if the max elements is 10, has only 10 points of evaluation. And
Right.
And one way to implement the curveback is to just go through the elements and roll a dice. And if this random number which is chosen is above the value of the curve at this point, then the element is chosen. And if you repeat this many times, if you go through the curve and roll a dice, and if it's above the threshold, then you select it. If it's not, then you then you go one element further, and then you roll the dice again and look if it's above the threshold. And if it's above the threshold, then you select the element, else you go one element further. And if you do this, then what happens is that the elements with the highest priority get, or how should I say it, the priority gets directly mapped to the access frequency through this curve and by the selection strategy.
Okay. So you can just use an array for that, presumably, then.
This is true.
Okay. And the hash table for looking up by names, presumably.
Right.
Okay. So, and then the size of the array would just be based on whatever the table size was. And then what do you use to store multiple values within a level? Well, no, it's not a level, but within a priority value within the array. So do you just use a list of some sort or a queue or something? There'll be actually no, there'll only be, well, there might be more than one though. That's the point. Yeah. So if you have multiple items with the same priority, how do they get stored?
No, I know what you mean. Right, this is a list.
Oh, it is a list. Oh, okay. All right. So it doesn't sound that different to level bag, in fact.
I agree. The main difference is that it doesn't have this this bad effect in levelback. Imagine in levelback if there would be levels which are relatively low, so low priority levels which are sparse. So only a few elements are in this. Those elements which are in this sparse low priority levels have a high selection probability, which might even be higher than this of elements which are stored in high priority dense levels.
Yeah, because there's not so many of them, therefore, yeah, okay, that's true. All right, okay.
And this was the biggest weakness of the levelback.
Right.
That it always chose when it sampled in a sparse level, then it just chose the next element, and so suddenly this element, because it was in a sparse level, had a higher chance to be selected.
Okay, and also there was a lot of waste in there because the way the algorithm worked, they were kind of split over 100 levels, given the way the short float worked, and the bag size might have only been 5. So you had an array of 100 items to search through to find one of 5 possible values. Yeah, okay. Yeah.
This is true.
Okay. I'm still not sure why that's actually any better at this stage than a sorted array where you select index based on a curve in the same way.
This is what curveback can be.
Oh, okay, fair enough. I mean, I know it has a sorting aspect to it, but I don't think it's actually any less efficient in the end. By the time you've dealt with empty array entries in the curve bag and put lists in place and cycle through your list to get the next entry, I'm not entirely convinced that just a sorted array isn't just as efficient anyway. I guess we could test that.
Mm-hmm.
It sounds a bit expensive to me.
Mm-hmm. I'm not sure. I think in 170 it was already sorted back, which means it was already just a array, and when multiple elements had same priority, they were just neighbors in this sorted array.
Yeah. That's the way I did it, to be honest. I did try all sorts of things. The difference was so marginal, it wasn't worth the complexity in the code. And it's kind of dead easy to get right when you've got a sorted array. Roman, are you still around?
Yes, of course I'm here.
Yeah, do you have any thoughts? Because obviously sorted arrays are not
Oh,
necessarily
some
the most
noise.
efficient
I
thing
really
in
have
Clojure.
problems to hear. Sorry, some noise. Maybe someone have to
I can hear
mute
it, yeah.
microphone.
Yeah, I can hear it too.
Is it at your end, Square? You had some sound problems.
Maybe.
Could you mute your mic a minute?
Yes.
Oh yes. Now better, no? Is
Yeah.
it better?
Yeah,
Oh,
better.
okay. Can you please repeat, Tony? Because
Yeah, Roman. We were talking about using a sorted array as one of the aspects of a concept IO bag. That which is fine in imperative language. I don't really understand the implications of that in Clojure, which is purely functional.
You can have like a sorted set there or anything else, because usually if it is sorted anything, it can be like tree, sorted tree, some red black tree, and it's okay for Clojure because trees are usually okay for, again, this noise. Trees are usually okay for functional languages and for these persistent data structures. So we can use something like this here.
Okay.
The
only thing I'm mentioning is that there's certain properties that are really critical. One is that it's indexed. And
yes.
one is that we can get the last entry.
Is someone scuba diving?
Whoa. Okay, I understand you, Tony. Actually, maybe you saw this. I don't remember priority map that I used for like very quick implementation of this back.
I saw that. It didn't have an index capability though. I mean, you could sequence it, but it wasn't indexable because it was a sequence.
No, why? It was indexable actually, because it was map.
It was a map, but you can't. It's not an O1 operation to get an entry. It's an ON operation to get an entry.
No. It was indexed. It should be so. I will check code. I will check that library, but it should be map, and it should have this
O1.
Yes, a constant time, but it will not be constant because it is like a persistent data structure, and it should be this hash array map tree, but it should be indexed. I don't believe that they didn't do this.
OLog 32 is fine with me.
Yes, it should be so. I will check, but I'm sure that it was, and it is indexed. So.
Well, if it is, but that would kind of work, because in fact we can just use it upside down basically, and we'll just reverse order of the sorts, because the only one we actually need to pull off is the lowest value, just to delete it rapidly.
We can play with it different ways, but I used it because we have these indexes there, and we have priority. So it is sorted and indexed.
Yeah, we never actually use priority as priority though. That's the problem. We only ever use it as the lowest priority. You never take the highest priority.
It doesn't matter because you can use there any like direction of sorting what you want.
Yeah, exactly. That's fine. Yeah. So as long as we can access it with an index based on its structure, that was kind of the question really. As long as it's structured in a way that index 0 is the highest priority or the lowest, whichever, and then index n, which is the end of it, is the other end of the priorities. And there's a a curve of those values in between. That's fine. That'd be great if it does do that.
Okay, I will check.
Okay, brilliant. It'd be nice if there was an existing structure so you can just use out the bag.
I have one more question about these task links and term links. How do you plan to make this general inference with actors in this case if we will use these term links and task links? So you have this calculator, how called? You have some actor that will choose concept and what will be done then. Do you understand the question?
Oh yes, we choose this concept for the concept correlator, which have a priority above a certain threshold, and these concepts are aware of the links of the with which other concepts they are linked to. So at this point, then we can already select the task link and the term link, and so we can select the belief also and can go into the inferencer.
Yeah, almost.
Okay, I have a question. I already have a question. Do you mean that this calculator it will contain all the graph of relations of concepts?
No. The active concept collator, it basically just every cycle it collects not every cycle, every inference period, whatever that is in terms of time, it collects messages from the concepts. And when a concept priority, as Patrick said, reaches a certain threshold, it will send out a message to the concept collator saying, I'm active. And it will just collect all of those for that cycle. At the end of that cycle, there will be a selection process made against that list of concepts. That can be a curve, whatever we want it to be, but we will select n of those concepts for inference.
Okay, okay, can I? So sorry for interruption. The question is, well, we have the collection of these active concepts inside calculator, and we choose one concept for inference, for general inference, I mean, and then how we will choose another concept.
Right. So what happens is if you say you set your number of concepts to select as 1, that one concept will be sent a message, which is an inference request message. And when that arrives at the concept itself is responsible for selecting a task from the task bag and selecting a term link, right? And then it sends a message to the target of the term link saying, I need you to pick me a belief. And then when it arrives at that concept, if that concept is active,
actually diagrams disappeared.
Oh,
sorry.
Okay, let me go backwards a second then. So I'm just changing my diagram to bring the right one up here. So we've got the concept on the screen here. So can you see my pointer? Is it moving around the screen or?
Yeah.
Yes,
yeah.
I see.
So general inference request comes in from the concept collator, and what this basically says is get me a task, get me a term link, and then it then sends those as a belief request message to the selected concept that's in the term link. Okay.
Yep.
All right, and then that comes in to that concept as a belief request message, which extracts the belief, adds it to the rest of that message, which is now an inference request message. So it's got a task and a belief, and it sends that to the inference deriver, basically, where the inference is carried out.
Okay.
There's a caveat in there that once a belief request message, if this message is received, but this concept isn't active, it doesn't do anything else because it's not an active concept.
Yes, I understand.
Okay, but if it is active, it also, what we were talking about earlier, it updates the term link between the two concepts. This is where that can get triggered.
Okay.
Because they're both active and they get updated.
One more question. Does concept know that it is active or not?
Yes.
Yes, this information is inside concept. Okay.
Yeah, it's basically its priority level determines its activation.
Yes. Okay, I got it. Okay. I had one more question, but I forgot. What was this question? I think that's all from my side.
Okay.
Oh no, I have this question. I remembered. So my question was, guys, do you did you think about the problems that maybe we will not have enough memory for concepts? Maybe we have to persist this data somewhere and move from in memory like architecture to some database.
Yeah, I've got several solutions to that. But to be honest, I don't think it's an issue. I think memory is cheap now. If we do need to go to off RAM memory, the obvious choice is solid state disks, which are pretty fast anyway. There are some issues with those, but they're kind of okay. There's two ways of dealing with this. One, which is the way OpenCog did it, which is, I think, kind of works. They have a third level in their priority. So there's durability, which is how important something is in the scheme of things to stay in memory. But you can have another level. They had them. They call them short-term importance and long-term importance, which was priority and durability. But they had another one which they called very long-term importance, which basically meant if you have to delete this, persist it to disk, and just leave a stub in the memory. So essentially, it copies it out to disk as and just leaves a reference in memory. So if something requires to use it, it gets reloaded. Which is it's basically just a virtual memory system, which is fine and would work. I honestly don't think it's necessary anymore. Memory is so cheap now.
This is also my opinion.
Yeah, it's so cheap that you can, a cluster. You're talking about terabytes of RAM. I mean, we're not going to run out of memory. It really is not going to be an issue. For people who can't afford terabyte clusters and they want to run it on a lower end machine, maybe. But I think, to be honest, you're going to run out of processing capacity before you run out of memory capacity.
Yes, I also agree. And a problem I see with persistence is that often you can't really predict when the concept will be needed the next time, and this can happen really fastly, and then the system is slowed down just to get this concept back from the disk.
Yeah,
while another system could immediately react.
I mean, I think you could apply some operating system theory here that, you know, a bit like working sets, same type of thing. There are some differences, but we still have an algorithm that we will have to have in place to delete stuff once memory's full anyway. So it's kind of an extension to that. It may be that you look at that, anything you're going to delete, and say, okay, this is a complex concept. It's got a lot of terms involved. It's been around for a long time. It hasn't been used for a little while for some reason, but it was expensive to create and it was used a lot in the past. We might want to store that on disk in virtual memory. But as I say, I don't think personally that we're going to need to worry about it. I think memory is not going to be a problem.
I also think so.
Okay, got it. Thank you.
Yeah, which is, of course, it's different to the general persistence problem of being able to save a memory image between execution runs. I mean, that's a separate problem, and we definitely going to need that.
Yes.
Yeah, I think the short-term approach for that is probably running a virtual machine and just save the whole thing.
No, it is very short term.
Yeah, absolutely. So, but I think it's really not a big issue to save concepts to memory. It's an easy process. You just serialize them out to disk and it's done. I mean, it's not a problem.
Okay. Okay. So absolutely all from my side. Yes, I asked all questions that I planned to ask.
Great, and I'm sorry, I still didn't really understand what your problem was earlier, Roman. But hopefully you've had some resolution towards it.
Actually, I didn't understand why we have to use these term links and task links, because I still don't have like all the picture for the system. So that's the reason why I will have questions. I am sure that I still don't understand a lot of things.
I'm in the same boat as well. So
I probably shouldn't have said it was unavoidable. That's probably, it's not technically correct. It is avoidable. I think the route that we've gone is a better approach. You could avoid it, but it would be nowhere near as efficient or as effective.
Okay, and now I really want to think about this. Actually, I have to think about this.
Great. If you can come up with another way of doing this, it'd be brilliant.
I'm not sure that I will, but I want to try.
Right. Yeah, absolutely. Have a go. You know, every time we get a new brain on the project, they come up with another way of looking at things. So that's always useful. It's kind of difficult for me because I've been looking at it for 10 years now, and whilst it's changed in that time, there's certain things that are kind of stuck in my head that this is how they happen. It always helps when someone else comes and has a look at it and says why. And I go, good question.
Okay, I see. So thank you.
Okay, anyone else got any points, questions, or comments?
Oh no. You could probably the draft we wrote is a good reference for the memory and control model.
Yes, I will check it again. I will look at this reference again. Draft. Okay.
Okay.
Right, thanks guys.
cool. Thank you so much.
Thank you.
Okay, speak soon.
Thank you.
Have a good night.
Thank you. Bye.
Good night.